Okay. Good morning, good afternoon, and good evening to all our honorable guests and audience from all around the world. It's my pleasure to be your host for the third day of the IEEE Global Conference on Artificial Intelligence and Internet of Things, IEEE GCAIoT. Today, we have two of the main activities of the conference taking place in parallel. We have the Industry Summit and the IEEE 5G Summit. Both are part of the industry and government track within the conference. The day program is full of insightful panel discussions and speeches from top figures in the academia, industry, and government sectors. I'm sure you will benefit a lot from this day. Don't forget to share your thoughts about the different activities in the event feed and write your questions to the panelists and speakers in the questions section of each session. As this is the welcome session of the day, please allow me to welcome Dr. Latif Ladid, the chair of IEEE 5G Summit, and Mr. Suhaib Sheikh, the chair of the Industry Summit. Dr. Latif, the mic is yours now to welcome your guests and the conference attendees.
Thank you, Chairman, and thanks to everyone joining us in this combined session between the Industry Summit and the IEEE 5G Summit. We have spent a lot of effort, to get some distinguished speakers into this event. As a matter of fact, we have 9 from the entire globe, 1 from Japan, 2 from China, 2 from Europe, 3 from the US, and 1 from Canada. And we'll be addressing 9 different topics that fit in very well into this event. So we're going to talk about 5G and Oran with Dr. Schilling, and then we'll be talking about blockchain versus data block matrix with our very good friend from NIST, Rick Kuhn. And then we'll be talking about IPv6 with our friend from all the way from China. That's Dr. Will Yu Su Sheng. As a matter of fact, I would like to stress the point that Dr. Isa has mentioned yesterday, that IPv6 should be also tabled on this discussion, since it's an internet layer, so not too many people really dive deeper into the internet protocols. It's a lot easier to look at the access technologies, which are a lot simpler to understand, also to do research on. And then we'll be looking at the impact of 5G on autonomous driving through Dr. George Pereira, who has been the leading light for the last 20 years, not only in IPv6, but on multiple topics. And this time, we'll be talking about the cross-border corridors. So basically, autonomous driving between different countries, especially in Europe, we have plenty of borders. So that's a very important topic where basically at the borders, not much access is done, and this is where the place to do that checking. And we have also a topic on 6G as well, with one of the distinguished speakers from the Finnish University of Oulu in the very north of the world, with Dr. Ari Potu, where he has the 6G flagship funded by the Finnish government for the next 10 years with 240 million euro. Then we'll have a look at the 3GPP, especially from the RAN side, with Dr. Satoshi Nagata. And we'll be having also the IoT vision from our famous Dr. Magdi Bayoumi from the University of Louisiana, who is holding for the second year the IEEE IoT Summit. Then we have our friend all the way from the Silicon Valley. That's Dr. Riyad Hartani, who's going to talk about the new space internet, looking at the intersection with 5G. And I'm sorry that he's going to be now all the way in the night with us. And last but not least, Dr. Sumia Sharkawi from Canada, who will be talking about AI-enabled edge computing. So I think we have a tremendous agenda that's going to look at all aspects of what this conference theme is how to get the digital transformation to happen at all fronts. I hope I haven't left anyone out in this discussion, but I will take my revenge when our session starts at the end of this session. Thank you very, very much. Back to you. Moderator.
Hello, Dr. Latif. Thank you so much for your welcome speech. Now, I would like to give the mic to Mr. Suhaib to share with us his welcome note for the Industry Summit. The mic is yours, Mr. Suhaib.
Thank you very much, Mr. Chair. And first of all, my compliments to Dr. Latif Ladid on an excellent program for the 5G Summit. I'm sure it will be very successful. My distinguished guests, participants, and our esteemed speakers from around the world, it is my great pleasure to welcome you to the Industry Summit at the IEEE Global Conference on Artificial Intelligence and IoT. As the chair mentioned, my name is Suhaib Kamasheikh, and I chair this Industry Summit. The summit spans over 2 days, that is today and tomorrow, of the overall 5-day conference program, and is primarily designed to provide industry practitioners with insights into various aspects of artificial intelligence and IoT. Over these 2 days, you will hear from industry experts through plenary sessions and panel discussions focusing on and providing use cases for digital transformation, innovation, strategic foresight, ecosystem development, operations, and cybersecurity. All of these in the domains of artificial intelligence and IoT. The program has been drawn up to provide practical knowledge and use cases from some of the most well-known and inspiring organizations from across the world. And it's not only that. The summit provides an opportunity to virtually network among peers and with speakers. You're welcome to attend our parallel events like the 5G Summit, which was just introduced, or the Women in Tech Summit, the government track, the technical track, and the Triple Helix exhibition. All participants will receive an official IEEE certificate with professional development hours. I would like to take this opportunity to thank our partners at the University of Dubai, IEEE Technology and Engineering Management Society, IEEE UAE Section, IEEE Region 8, the International Telecommunication Union, the Telecommunication Regulatory Authority of the UAE, the National Telecommunication Regulatory Authority of Egypt, IEEE Women in Engineering, Burj Al Arab Innovation Cluster, 5G World Alliance, IPv6 Forum, IEEE Communication Society, Zayed University, and Emirates Science Club. I want to also thank Dr. Isa Bistaki, Dr. Fatma Tahir, Engineer Robert Beerwolf, and Engineer Mohammed Aboud for their untiring effort and support to the Industry Summit. Lastly, I want to especially mention my team, Faisal Al-Khaldi, Mohammed Abdul Jalil, Khalid Mukhtar, Mohammed Khwaja, Mariam Al-Thani, and Mohammed Abu Al-Arin. Without their work over the last 8 months, the summit would not be as insightful, holistic, and practitioner-focused. I sincerely hope that you will learn, network, and enjoy over these 2 days of the summit and throughout the conference days. The agenda available on Eventus provides details of all sessions. I would recommend you to join as many as possible so that you can get the maximum benefit out of this Industry Summit. I thank you for your participation, and I'll be available throughout the day for networking or any questions if needed. Thank you. Mr. Chair, back to you.
Thank you so much, Mr. Suhaib. I think this is all for the welcome session, and it's time to start our industry summit and IEEE 5G summit. Interesting programs. Our dear audience, please join the running sessions from the tab called Live on the left sidebar. Have a fruitful day, and see you again soon.
خش على البنات الثاني. خش بسرعه على البنات.
Welcome to the third day of the IEEE Global Conference on Artificial Intelligence and Internet of Things, GCAIoT. Our honorable audience and guests, I would like to remind you that you can network with the conference attendees and speakers from the right side of the screen in the People section, and share your thoughts and ideas in the event feed. Don't miss this opportunity of meeting lookalike minds from all over the world. Also, during the sessions, you can share your questions with the speakers or panelists through the question section in each session. It's the time for the first panel today. Either you are in Cairo, Dubai, New Delhi, or even New York. Your city will definitely face a future that we have to be prepared for. About the Cities for Digital Future, we are having this panel. This panel has representatives from different countries, from Saudi Arabia, Oman, and the United Kingdom. The panel moderator is Mr. Faisal Al-Khalidi, CEO of Linkers IoT. The floor is all yours, Mr. Faisal, to welcome your guests and start this insightful panel.
Thank you very much. Appreciate it for the nice welcome and warm welcome from GCAIoT. I'm really thrilled to see such an event that brings bright-minded people together talking about the future of cities. First of all, let me introduce my wonderful panelists. I have with me here on the call Engineer Mansour Hanif, Executive Director, Technology and Digital Infrastructure at NEOM. Engineer Hanif holds more than 25 years of experience of planning, building, optimizing, and operating mobile network around the world. Worked before with Orange, T-Mobile, British Telecom, led converged networks, R&D labs, as well as multiple CTO positions. And recently he's leading an executive director position at the future city of humanity located in Saudi Arabia, NEOM. As well as a member of steering board at UK 5G Innovation Network and advisory board of the satellite application. Welcome, Engineer Mansour. As well, we have on the panel today, Dr. Huda Shweli, Chair of Smart City Platform Oman. Dr. Huda is the chair of Smart City Platform. She is an academician on IT enthusiast, as well a researcher for innovation, an effective leader of change and management. Dr. Huda obtained the PhD degree in computer science from Glasgow University, United Kingdom, and received her master's degree of science in software engineering as well in Manchester University. Welcome, Dr. Huda. I have also on the call Dr. Maher Shira. He's a smart city expert and digital transformation advisor. Dr. Maher has been leading leadership positions and innovation positions in RTA since 2011. And recently, Dr. Shira is leading and advising His Excellency Fahad Rashid for Smart Riyadh. Dr. Shira has a PhD in innovation from the University of Dubai, as well as is one of the, he's also one of the bright examples that we are proud of in GCC. I have on the call Engineer Shuaib Kabar Sheikh. He's the chair IEEE Region 8 Vice Chair for Technical Activities, an award-winning ICT and smart building consultant specialized in digital transformation for building into smart properties, which enhance experience of building stakeholders, lower energy consumption, enable data-based governance decisions, and reduce capital and optimization operational expenditure. I'm really humbled to be amongst leading stars in tech, smart cities, and future networks, and be thrilled to have this session with you today. So, at the beginning, our today's panel is formulated around 5 points. Introduction, and I hope I'll leave the floor for you now to speak about yourselves, each one. Then we'll talk about what changed after COVID. Then we'll talk about how do we define resilience in smart cities and the future of humanity and digital economies. Point number 4, what are the challenges that we may face in this and how are we addressing them? And point number 5, how do smart cities support and enable the future of digital societies? The floor is yours. We'll start with Engineer Mansour, then Dr. Huda, then Dr. Ma, then Engineer Shoaib.
Well, thank you very much, Engineer Faisal, for inviting me to this wonderful forum, and I'll take a few minutes just to describe a little bit about NEOM for those who aren't aware of NEOM, and then a couple of words about what my role in the cognitive cities, as we call it here, is in NEOM. So first of all, hopefully some of you will have heard of NEOM by now. We have very ambitious goals, which are numerous, but I think I could summarize them in one phrase, one sentence, which is to accelerate human futures, human progress across all domains and across the wonderful diversity that is humanity, which I think is a very lofty and noble goal and certainly has attracted me to NEOM. And I think if you will have heard about the scale and scope of NEOM, positioned in the northwest of Saudi Arabia, in a location which has always been the crossroads of humanity from the beginning of time, really. And now it's not only a crossroads of humanity, but it's the crossroads of data, moving increasingly from east to west, a very strategic, well-chosen location, and within reach of 40% of the world's population. So apart from the location, we aim to attract the world's best minds to NEOM to help us build this future, which will be also based on a future-looking approach to a legal framework and regulation that supports innovation within the overall framework of Saudi Arabia. It should be an international community in Saudi Arabia with full support from the ecosystem in Saudi Arabia and interaction with the Saudi Arabia ecosystem. But we really want to concentrate on innovation, and technology is going to underpin all of we do, even though NEOM is going to be composed of multiple sectors, up to 15 or more sectors, because we are also aiming to have a thriving economy based on the diversity of those sectors. So summing up in the 3 key pillars of NEOM, which will allow us to accelerate that future, are first of all a thriving economy. We believe that we have the right conditions in NEOM to promote through public and private investment, thriving sectors, diversified sectors over the years to come, to achieve a population of up to 1 million by 2030, residents and people who will be working and living in NEOM. But also based on a new approach to conservationism, to conserving the environment, and also a sustainable economy, and a sustainable approach to everything we do is at the center of everything we do. So I would say those are the 3 key pillars of that. But we have I think a completely original situation and approach, because we are building the digital version of NEOM, including all of its sectors, before the physical NEOM is built, which is a tremendous opportunity to make the best use of digital technologies to create a sustainable future. So I think that is the key part of which is completely original in NEOM, apart from several other aspects. In my own role, I've been here since February, so about 10 months now. And initially, my role was within the technology and digital sector. My role was focused on getting the basics up and running. So we've been very busy, working very hard the last 10 months to start rolling out our fiber infrastructure, our 5G infrastructure, and we're now finalizing our first agreements for subsea cables to land in NEOM. So all of that is now in motion, and we are moving to the execution phase. And next year, we'll be looking at bringing in
would be very much the key element to address the needs and the direction to figure out all the necessary technical solutions going forward to address the energy, the cost efficiency, to provide the necessary agility for the reconfigurability, and to cope with the complexity and as well as the customization needs of 5G era. As a matter of fact, I often feel that we are in a very interesting phase of our industry. Namely, I believe from 1G all the way until 4G, we were dealing with opportunities and challenges of CT technology, communication technology, basically. But starting from the first day we started thinking about 5G, we are actually entering the phase of IT and CT convergence, the true convergence, which is the what we have been talking about since the 90s, ICT convergence, but not until I think the day when we started the 5G effort, the true ICT convergence has started. And in this phase, I believe being efficient and being agile, basically being green and soft, has been the pursuit. But at this point, I think going forward, we will have yet another interesting transition phase, which is now bringing in the DT, which means IC, IT, CT, and DT, three domain technologies is going through the phase of a deep convergence, where we bring, in addition to green and soft, the efficiency and agility, we are bringing the open and smart intelligence into the picture. And it's a very interesting and I believe will be a greatly rewarding journey, but it's not to say that it's an easy journey. And some of you might have seen this chart that I have shared over the past few years with various audiences. Actually, our radio access network transformation has been a long journey since 2011, I believe, when we identified that the centralized, collaborative, and the cloud RAN, which means CRAN, is the path that we need to follow. And it's been a very interesting journey, because along the way, we needed the help from not just 3GPP, but actually started with ETSI and NFV initiative, and then IEEE's NGFI working group, and also ITOT's 5G focus group. All of these different organizations were very helpful and essential in bringing us to where we are today. And another element about bringing in the intelligence, actually, we started very early in 2014, exploring what we call the wireless big data and AI for RAN. But we failed in 2015, 2016 in injecting this technology into 3GPP's 5G effort at early stage. So yet again, we had to basically get help from other organizations along the way to bring us to today. And the organization included WAIA, Future Forum, WWRF, ITOT, and then finally, I think we are on the right track with all the key players in going forward with embedded intelligence in our technology solutions as a key element. And I think one particular effort in our ecosystem was mentioning, which is part of the title of my talk today, which is ORAN. ORAN aimed for an open and smart ecosystem for 5G RAN, as it was declared at the beginning of 2018. And open actually stands for Open Interface, Open API. It also stands for open source software and open reference design, aka white box hardware. And smart, of course, embedded or native intelligence is what we are seeking in our network, particularly end-to-end, including the RAN. And ORAN has grown very fast. As of end of October this year, it has grown to 237 members. As you can see that in addition to 27 operators, which actually spans all 5 continents, covered probably, I think, more than 90% of the global population under its collective network coverage. But also it has more than, 200 contributors that comes from all sizes and shapes, both traditional CT technology providers, as well as the large IT or DT technology providers, in addition to SMEs, startups, and also academic institutes. And together, they are working on the ORAN reference architecture that basically builds upon the 5G RAN from the edge all the way through CU, DU, and RU to the end. But in addition, it adds the intelligence through the 2 rigs. And there are a total of 9 work items that are co-chaired by 2 operators and 2 vendors, respectively, each of the working groups, as well as 3 focus groups and an open source community. Altogether, they've been working really hard and with a great enthusiasm and momentum. And let me start with some examples of their effort in terms of open. As I said earlier, the open interface is a key which enables disaggregated RAN, which helps to bring in new players into the ecosystem and enable the mix and match of both hardware and software capability or solutions that becomes available. And the open reference design for the hardware is one of the key features that this community strives for, to provide in order for the ecosystem transformation to be efficient and also an open arm for newcomers, because players with diverse domain expertise will be able to participate with this kind of decoupled both horizontally and vertically in our system. It actually, in a way, it significantly lowered the technical entry barrier for new entrants. So any new players that has some specialty in a particular piece of software or in a particular aspect of a hardware can bring their value very easily into this kind of a new ecosystem. Okay. This definitely also bring in source diversity for a much healthier ecosystem development. And in the past 2 years, 2020 is still here, not over yet. But in 2019, the white box has been put in the field, but it was based on 4G. And this year, there's a lot of trials and small-scale deployment for the 5G of the white box. And if you look at ORAN's Alliance's joint effort in the white box, you will see that it started with providing the open reference design hardware for indoor picocell, outdoor microcell, and outdoor macrocell. And next year, the outdoor picocell will also be provided. Now, another aspect of the open source community, actually, the Alliance, together with the Linux Foundation, had launched a software community officially in April last year. And then about 6 months or so later, the first release of the ORAN open source package was shared with the global community, namely Amber and June somehow it was not successful at that time. And so in the meantime, when O-RAN Alliance was launched, we focused on bringing in the originally envisioned for RDA capability into the RIC, the RAN Intelligent Controller, which actually envisions 3 different control loops in the RAN. The non-real-time control loop, which we see that would be handling more kind of between a management plan and control plan function for more than a second, above a second time frame that can go into minutes or multi-minutes, of course. And then the near real time would be really properly in the control plane, which would be centered around 100 millisecond time loop, the control loop. Okay. And finally, the actual real time, which in our first phase, we don't have a rig set up for it yet, but this is certainly implied, okay, which is maybe at the millisecond level of a control loop. Then there is a division of labor, of course. If we look at the non-real-time rig and the near real-time rig, the non-real-time rig would be basically providing guidance and the key parameters and policies, and also maybe the machine learning and AI models to support the operation of the near real-time rig. And of course, it would also provide some non-real-time optimization and setup for the RAN elements. Whereas the near real-time rig, actually through some key interfaces that O-RAN Alliances provides or propose, it would basically provides more fine-grained data connection and also the necessary control action to the nodes below. Now, this kind of hierarchical setup provide a very nice division of labor between the non-real-time rig and the near real-time rig. You have A1, and also for the SMO, you have an O1 connected to the near real-time rig. And the near real-time rig has an E2 connecting to the G node B or CU or RDU. Okay, and then you need
Amazing. I see a lot of passion over there, and I see I echo on what you said. And recently, we can say COVID-19 becomes our CTO, accelerating digital transformation in all aspects, not only in companies but also in cities. Speaking about what's changed, what can you tell us, Dr. Maher, about Riyadh? How did COVID-19 change the way we look at smart cities in Riyadh and the way Riyadh is planning its future?
Well, I wasn't really thinking about it from only Riyadh point of view. I wrote some comments here. Of course, I don't want to repeat what my colleague said. And I believe what Engineer Mansour and Dr. Huda referred to is obviously on spotted. But what has changed? And immediately what came to my mind is a statement that was mentioned by one of the leaders that technology has finally paid back. Now, yes, maybe COVID-19 accelerated transformation, but we can't say that it's a bliss. Obviously, it was a tragedy, and we want to avoid this kind of tragedy. And therefore, yes, we have to be prepared, we have to be aware, and we have to be ready. But that statement actually was first of its kind. Technology has finally paid back, and the other statement was, if we really want it, we can do it, and stop making excuses. We've been pushing back video calls. It was there. The technology was there many years back. We've been pushing back virtual meetings simply because we didn't either trust the technology or we didn't want to do it, or we thought that it's more complicated than physical meetings. I'm not saying that physical meetings are not really required or recommended. Obviously, we need to still socialize. However, we didn't really give ourselves the chance to test and endorse these technologies and many other. I also remember His Highness statement that life after COVID-19 will not be the same as the life that was before. Obviously, this is really, I look at it as a very encouraging statement to think differently, not to be afraid or worried about the future. We have to accept the fact that things has changed. We have to adapt to the new way of doing things, and some of them are actually good practices. I mean, social distancing has always been a good practice. You don't really need an event to tell you to stay clean, right? These are good habits. And the third thing I was thinking about is when it comes to city, and what COVID-19 actually showed us is many smart cities are not really smart, right? They may claim that they are smart, they have technologies, but they are not really using those technologies the right way. And that tells me clearly that smart people remains in the heart of smart city. If you don't have smart people, well, there's no point on having all of these smart gadgets and all of these smart technologies. So again, I believe COVID-19 have proven that it's all about people. It's how you educate your society, how you make your society more aware of these technologies, and how you use them to be more resilient, more efficient, and more effective. I believe this applies not only on Riyadh, on everywhere. And if I look at Riyadh and some of the cities in the region, they proven the other way around. They proven that maybe we were not talking much about smart city, but we actually had proven to the world that we are much smarter than many other cities. The way we reacted to this pandemic, the way the apps, the citizen engagement, the structured lockdown, the new policy that was issued. There's a lot of things that prove that the government and the society were aware, were ready, obviously with some challenges here and there, that's for sure. But in general, that's actually an achievement by itself.
Amazing. When you said smart people are in the heart of smart cities, and cities are built to serve people, and we need to empower lifestyles with technology, not force people to use technology for the sake of technology. I love that. Engineer Shuaib, to you, what can you tell us about plans of IEEE, or what's happening with technology standards that could help us overcome such pandemics in the future?
Thank you, Engineer Faisal. My distinguished colleagues on the panel made some very excellent points, and I would like to actually start by building on top of that a bit. COVID-19 has had and continues to have devastating effects throughout the world. But for smart cities, I believe it actually showed a silver lining, because COVID-19 provided proof of some of the benefits of smart cities. My colleagues belong to cities and countries which are very forward-looking and have the economic output to support excellent and advanced smart city activities. However, there are many other cities across the world which either do not have the financial power or the political backing to actually embark on large-scale smart cities efforts. And I think COVID-19 actually showed these cities how useful technology transformation in cities could be, because there is already data coming out. There are some IEEE papers published on it. There were, and in conferences I heard, but in other areas as well, there's already data coming out which shows that cities which had the right infrastructure were able to react faster and act faster. As Engineer Mansoor mentioned, they were able to utilize the data for insights very quickly and actually move towards solutions a bit faster. We have seen a greater utilization of digital tools in public services in many parts of the world. But a very interesting sort of example that I want to share with you over here is that many cities actually reprioritized their programs to focus more projects which actually could help with the pandemic, and this was done mid-pandemic. The example I want to give is my own city, the city of London, where they reprioritized and implemented the London Air Quality Sensor Network. And the reason it was done was that it was helpful in actually measuring and getting clear data about the vehicles as well as individuals in a particular area. And that actually helped them down the line with introducing, monitoring, and policing local lockdowns. So this is a very key example where a city was able to react and utilize technology for the benefit of the city itself and for the health and well-being of its citizens. But at the same time, there has been an economic impact, and funding, especially on public projects, is always limited. Even in public-private partnerships, some concerns have come up. An example I can give you is the Google's parent company, Alphabet's affiliated Toronto Smart City Waterfront Development. They pulled the plug on it in May of this year, citing the economic crunch due to COVID. And this may be seen in other parts of the world. Budgets will be tightened, business cases will need to be more solid. So a very important point that my colleagues made around digital transformation, I would add that digital transformation needs to be prioritized and done in a manner which has the largest impacts on the city and especially its citizens. I would also, while my colleagues were talking, I wrote down a few points which I want to sort of bring up. There was mention of better air quality. And actually, there is an increased focus on healthy assets and healthy buildings now, where along with the air quality, the general focus has increased on the health and well-being of occupants. Within cities, high streets have been impacted, and high street is a term used in the UK for the primary retail business street. If I take that to other parts, it converts to malls, it converts to shopping districts, etc. And those have had a devastating impact, especially on their footfall. And work needs to be done around there, and there is the potential. And there will be changes to actually recover from this footfall, but at the same time, there will need to be a lot of thinking around what
do. Let me explain a little bit more why this traffic congestion is generated in the center of the city day by day. So you know that most of us do not take public transportation because they are too far away from where we live. So we are not taking public transportation, and instead we are taking our own private car. But if we are taking our own private car, generally only the first mile, it's the one that we are alone. So we are alone in our secondary street. Afterwards, when we are in the main roads, generally there is a very high probability that we are going to roughly the same destination. So, as you see in the left side of this slide, you see that we, of course, create congestion, right? And there is an average of 1 to 1.2 people per car. On the right side, you see concept of next. So you can call it car jumping. Jumping, you can think about that as people that are find themselves on the same main road at the same time going into the same destination. They generally create a congestion and traffic, but in this case, if they shift cars, so they literally jump from one car to the other to consolidate in just one unit, one car that is going to the destination, they will create much less traffic while having a very ubiquitous service in the first mile, because you start again with your car. Of course, this is very difficult to do with the regular cars because you need to have some parking space to park the car and to do this kind of swapping of people between the cars, redistribution of people between the cars. It's absolutely difficult to do with regular vehicles. And so this is the reason why we created the vehicles that you see in the bottom of this slide, because they are basically something that it's in between the taxi or Uber or any private car and the public transportation system like buses, trains, and metros. Why? Because the first mile, again, is done as it was a taxi. So the vehicle, it's coming to your house because you order for this vehicle, the single vehicle, and you go inside of the first vehicle. While on the other side, when you are in the middle of the road, this vehicle can do what we call transfer in motion. So it's like a coincidence, it's like a connection between two buses, but they connect physically together, so you don't need to stop. You don't need to go out and step up to another vehicle. It happens, everything in motion. So the consolidation of these people, of these passengers, happen absolutely in motion without any stop. So finally, the travel will be, as you see here, much faster than a travel with the bus, because you cut completely the first mile. So the walk to the station, the bus station, you cut every stop in the middle, and then of course the vehicle will directly bring you to the final destination. And it creates much less traffic than a traditional ride-hailing system like taxi or Uber, because the density of people, it will increase while you're going to the center of the city. So it does remain 1.2 people as we've seen before. So let me explain a little bit more about. You see in the image on top of it, the section of one of our vehicles, of two of our vehicles docked together, sorry. The main innovation, the unique feature of this vehicle, it's that when they are connected together, the doors that are also in the front and on the back of the vehicles, so not only on the side like regular buses or cars, they allow people for walking, for moving between the two, in this case, units. Of course, they can be more than 2 units. When they walk between them, in this moment, you can consider this like a bus connection, but without any stop, because everything happens in motion. The vehicles can connect, can dock together in motion, and can move the people in motion while they are on the road. So this kind of thing, of course, can improve a lot the pooling of the people from the origin to destination. And this very concept, this very part of our project has been studied also by the New York University. So in this case, the New York University ran, let's say, a basic version of our algorithm, optimization algorithm, and the result was really amazing. I mean, about 60% less distance traveled by the entire fleet to bring to destination the same amount of passengers compared to a taxi or any other non-modular system. So in this case, the modularity is the key. The modularity intended the fact that those vehicles can dock together, and when they are docked together, they can
Again, as an electrical engineer, you know that if you solve the problem at the borders, then you solve the problem everywhere. How are we addressing this? In the scope of Horizon 2020, the Commission launched the first call on 5G cross-border corridors for CAM in 2017, with the objective of identifying the problems and barriers and providing a blueprint towards accelerating the deployment of 5G for CAM in cross-border scenarios, and in general in areas where there would be no business case and therefore deployment would not happen, or where there are identified mild market failures and therefore deployments risk being substantially delayed. This first call resulted in 3 projects which were launched November 2018, addressing quite distinct scenarios. 5G Carmen, the Brenner corridor linking Germany to Austria to Italy. 5G Crocu, the French, Luxembourg, Germany triangle. And 5G Mobix, 2 corridors, Portugal, Spain, and Greece, Turkey. These cover over 1,000 kilometers of highways and cross 8 borders. They represent a combined EU funding of 63 million euros. A second call on 5G for CAM was launched end of last year, this time with a focus on automotive and or rail. 3 other automotive projects with a small rail component have recently been launched, again with quite distinct scenarios. 5G Blueprint, the Belgium-Dutch corridor linking the ports in the North Sea. 5G Routes, the Baltic corridor linking Finland to Estonia, Latvia, and Lithuania. And 5G Med, the Spanish-French corridor through Catalonia. They cross 5 borders and represent a combined EU funding of 31 million euros. Finally, a rail-focused project was just launched with around 10 million euros EU funding, with specific focus on critical rail services. The previous cross-border corridors are a small part of the Trans-European Transport Network, which spreads throughout Europe, across all the member states, the associated countries, Norway and Switzerland, and the candidate countries in the Balkans, plus Turkey. They are marked in the map in red, the first call, and in white, the second call. And they provide a good sample of the variety of scenarios across the continent. These 7 projects involve a total EU funding of over 100 million euros just to prepare the grounds for deployment. The ongoing first CAM call projects have already identified a number of challenges toward deployment, which go beyond the technology aspects. They include, beyond the technological aspects relating to 5G radio, core, and MAC, 3GPP releases and equipment timelines, road infrastructure instrumentation and ITS control centers, vehicle equipment, etc. Also, business model issues. The competition between telco MNOs, automotive OEMs, and road operators is important, but now they need to cooperate to agree on co-investments to deliver cross-border coverage. Legal and regulatory issues are also important, from GDPR to access to data, namely across borders, and the all-important security and privacy, reliability and availability, and liability issues. All these would deserve considerable attention. But let me focus on some major challenges around the provision of advanced, connected, and automated mobility services. Providing pervasive coverage across Europe, satisfying the requirements coming from advanced CAM services and real-time services, seamless even across borders, will not be easy. And certainly, best effort is no longer enough. The objective is to provide seamless roaming of CAM services on top of other, including eMBB data services. This requires a different kind of roaming, no longer just voice, for which agreements exist. Best effort is not enough. But in order to deliver up to the requirements, it comes with a price. Real-time services are indeed critical. Some CAM services require real-time connectivity, and this is not possible with the majority of current deployments. Considerable upgrading investments will be required. Here, the location of the MAC is a critical element. Let me now give you two examples from our 5G Mobix project. Let's first look in detail into the Portuguese-Spanish cross-border corridor, which is part of the 5G Mobix project. This cross-border corridor links Vigo in Galicia, Spain, to Porto in the north of Portugal, with the border between Tui, Spain, and Valencia, Portugal, over the River Minho. The border is constituted of two automotive bridges, one old and one new. Testing will be carried out in the old bridge. Just to give you an idea of the kind of services being considered, here is an example. One of the use cases under consideration is an electric automated shuttle operating across the bridge over the river. Two scenarios will be addressed: cooperative automated automation and remote operation. In the first scenario, we have a vulnerable road user
is moving very, very fast to this new future, which is offering opportunity for all. And I hope it will be a catalyst to bring people together, to innovate, and be braver and courageous enough to move faster with the new technologies that can serve all of humanity.
Yes, sure. Okay, thank you so much, Dr. Mansour. Thank you for being with us in this conference, and it was a pleasure having you. We can't wait to see you next year. Thank you so much.
My pleasure. Thank you so much for inviting me. Thank you very much.
But can this solution be generalized? Does it scale? In fact, that solution is easier said than done. Many other MECs would have to be deployed across Spain and Portugal, obviously, and this not only at the borders, and this for each operator in each country. Considerable investments will be required just on the MEC side before we could deliver some advanced real-time services. Just looking at the border between Portugal and Spain, there are 7 major borders served by major highways, signaled in the map, but there are another 12 important ones. So, considering just the major borders, we would need 7 times 6, 1 per operator on each side, i.e. 42 additional MECs. Considering also the other important borders, we would need up to 116 MECs just to ensure continuity of service across the Portuguese-Spanish border. This is a huge investment, even if done over time. And obviously, CAM alone would not justify it, even if considering life saves through increased safety. In fact, most sets are not in highways. Let's now look in detail into the Greek-Turk cross-border corridor, also part of 5G Mobix. This corridor links Thessaloniki on the Greek side to Istanbul in Turkey, and we are looking at a border circled in red in the picture. Remember that, as I said before, 210 kilometers of fiber correspond to 1 millisecond delay, which means that 100 kilometers distance corresponds roughly to around 1 millisecond round-trip delay. So, in the Turkish side, with the MEC in Istanbul, this entails a round-trip delay of roughly 2.5 milliseconds already. And even if one was deployed in Terkirgat, there would be still 1 millisecond round-trip delay. On the Greek side, going all the way back to Athens, would require 8 milliseconds round-trip,
2019 in September. But let's go and have a few facts of our 6G research program in Finland. We have a funding instrument called the Academy of Finland. The government of Finland decided in 2017 that we should put some effort into certain areas which are strong in Finland in the format of flagship programs. Then there was a 2018, late 2017 and early 2018, there was a call to submit flagship proposals for the Academy of Finland. And out of approximately 50 proposals, this 6G flagship program was selected to be the number one and was awarded the flagship status. The program started at the beginning of May 2018 and it will last to 2026. Now, the volume that we expect to see of this program is about 250 million euros. Of course, it's not all coming to University of Oulu, but for the ecosystem that is working with us in this program, including, for instance, Nokia, Keysight, InterDigital, as well as VTT, Aalto University, Business Oulu, and Oulu University of Applied Sciences, and other companies as well. Now, currently, we are about 300 experts at the University of Oulu, and the whole program is operated by University of Oulu, and a couple of numbers later on of the size of the ecosystem and the results that they have provided so far in the next slides. Now, in the beginning, what we decided was that we need at least these 4 research areas to support what we expect 6G to entail. Obviously, the wireless connectivity is something that a Center for Wireless Communications, where I come from, would be deemed obvious choice for 6G program. And what do we actually want to achieve with these new wireless connectivity enablers? A couple of things at least. One, to push the data rates up to close to terabit per second range. And second, even further diminish the latency and especially the jitter in the wireless air interfaces. Now, if we think about going to terabits per second, this basically brings us to the second research area, the devices and circuits. Terabits per second basically requires tens of gigabits of tens of gigahertz of frequency spectrum, if not even 100. And these kind of bandwidths are just simply not attainable in lower frequency bands where we currently see our systems. Now, then we come up with the problem that the current semiconductor materials start to have really big difficulties when we go beyond 100 gigahertz in the spectrum domain. And also when we go to higher frequencies, also the circuit structures need to be redesigned since new kind of phenomena start to appear in the devices. So it means that both we need to look at the current materials and how to make them work in higher frequencies, find maybe new materials, and then rethink how the circuits are done so that we can actually draw some power out of these devices. So this is a really a big challenge and area which requires huge efforts from the global research community. Third area is the distributed computing. Now this means a couple of things. First of all, it means that the computing itself needs to be brought really close to the services so that all the latencies and all the jitters can be controlled, at least locally, very efficiently. And the second thing, what it means is that we need to introduce machine learning, AI type of algorithms to control many things, including the waveforms, but also doing computation for services locally. For instance, let's say collaborative robotics. And you need some kind of smart algorithms to run those. And now when you start thinking about machine learning and AI, and we talk about wireless environment, which is extremely dynamic, where data becomes more or less obsolete after 1 second, even after some hundreds of milliseconds. So what we are talking about is not your traditional AI, where you have a huge amount of data which you can mine for days or even weeks and then get some meaningful results. No, we need now a totally new type of family of algorithms that are able to make assessments and decisions within, let's say, a few tenths of milliseconds, if not even faster. The fourth area then covers services and applications, which can mean many things. First of all, it looks at different verticals and tries to come up with true requirements together with the vertical experts, what is expected of 6G system in particular vertical, may it be health or energy or industry or whatever. And that is something that we now try to take on board already, the vertical experts in the beginning of the research, and not try to use the technology push approach, but also try to involve these guys in the beginning of the system definition. And then on the application side, you can start to see we've been doing a lot of research and demos on AR, VR. There are new kind of things coming up with the displays in the car windows, and even in the elevator walls or whatever. So it's a very versatile and interesting and very experimental driven area, this services and applications. So we have these 4 research areas: the wireless connectivity, device and circuit technologies, distributed intelligent computing, and these vertical applications and services. And these basically gives us our 6G flagship goals. First, support the industry in finalizing the 5G and figuring out
your mic is okay
nice
now.
ways to deploy 5G in different vertical industries. And the second and the more blue sky and the fundamental goal is then to look at the enablers for 6G.
Can you hear me, Dr.
And
George?
then the third area
Yes.
is to speed up the digitalization of society.
Yes, I can hear you. Everything is going well.
5G and 6G
Give me 1 minute, and our
the output that we
interviewer
expect
will
to see,
be
of
with you
course, are
right
5G
away.
and more so in the coming years, 6G components and systemic models. And as you can see in the results box, the number of publications in the last 2.5 years is rather high. We have more than 1,000 peer-reviewed publications. We have 46 doctoral degrees already.
Thank you for the session, and thank you for accepting this interview.
And then these white papers, and one of them I will take into a more close look in the later on in this presentation. And the impact that we expect to see is that we really try to involve the vertical industries in the 6G research, but also do demos so that the digital value and the strategies of the companies are reflecting their digitalization aspirations in the future. And obviously this gives us eventually the vision so that it's the data which is in the center of this whole show. So it's a data-driven future society, but it's enabled by a near instant close to unlimited wireless connectivity. So this is the vision of our program. The integration
very successful experience we are having in IEEE with these conferences will make it more and more likely that at least a certain number of participants.
And due to the fact that
they will lose a little bit of the networking aspects of the conference, but it's also important that this enables some people that otherwise not be able to travel,
and that is
because they just don't have time
that will open up a myriad
so I think this will stay, but
possible applications
in parallel with the normal conference.
And complemented with mobility and artificial intelligence / machine learning,
more easier.
We totally open up a new business domain for wireless communications in the future. Now, I mentioned these white papers. So we have in 2019, we provided this white paper of key drivers and research challenges for 6G ubiquitous wireless intelligence.
Okay,
and this year we have provided these 11 white papers.
I was saying it, making it more easier.
I seem to have received a message from...
as you know, the conference objective is to support the integration among academia and industry.
It was not for me. So,
this technical
this white papers cover large area of different aspects.
Again, this is very positive.
Not just the technology. Obviously, there is technology. There is
the focus was strictly academic. We have moved forward, and there is an increase in industrial participation and industrial focus. It's not as if industry did not contribute before with papers, but now the
6G. I'd also discuss one of the papers discusses also what are the drivers beyond
involved
performance
in IEEE. This has been one of my
United Nations
focus is exactly to
Sustainable Development
industry
Goals as value indicators of our
the involvement of governments is becoming more and more important as they are facilitators.
More than 250 global experts joining us
allow
in these
the
different
transfer and deployment of technologies.
Provided these
so I think it's extremely important that they
you can see the address where they are available.
Dr. George, you must have attended tens of conferences this year. What is the most interesting thing that you like about this one?
I will come back to this a little bit more
It's again this variety from normal technical contributions
in our
to industry,
University of Oulu, we have
involvement
what we call this 5G
government participation. I think this is an important aspect because it provides also guidance.
So we have a lot of radio solutions available.
It is important.
Millimeter wave 5G, indoor, outdoor, 3.5 gigahertz, 2.3 gigahertz.
This broader perspective that everyone has a role to play and everyone needs to
obviously all the previous generation, well, not all, but 4G is there. But we also have narrowband IoT Cat
was planned to take place in Expo 2020, but this plan was postponed.
edge computing
So Expo is our next station.
Several
in your opinion, what is the impact of being part of this massive event?
Available standalone network capabilities are
again, as I said, the contributions I have seen today just on this 5G
management tools,
5G summit,
there are some already running and some will come
and again, they will point out to
and then we go towards in all of these domains to come up with the next generation of 5G devices, eventually coming to
everyone is interested in deploying as fast as possible, but I think everyone has
acquired one which operates at 270
is extremely important because it brings an extra dimension
being tested at the moment.
Yeah, I think it would make
but that's not all. There are many more things that need to be done. For instance, in the standardization and regulation, we are helping
we are waiting to have you next year with
company customers.
Thank you.
I hope so.
Not really being ourselves in the standardization
Thank you so much.
fora, but
Thank you for the
providing a
nice
lot of
conference.
results
Thank you for the
they can utilize in providing next generation standards for 5G and then beyond 5G and 6G standardization. Other thing that we do is look at the regulatory issues and even legislation issues in terms of looking at what type of business models for running these networks, for instance, could be there, and which could be valid and valuable for certain kind of deployments. And research teams are also in this slide. So there is a lot of 6G this, 6G that. So as I mentioned already in the previous one of the previous slides, that we need this terahertz technology enablers so that we can find ways to do the circuits. We need new fundamental waveform designs, and then figuring out how this localization, sensing and imaging and all these kind of different new opportunities, how do you make them work in a consultation with the communication signal itself. Now let's go into one of the white papers where we discuss the verticals and the values driving the future. In this white paper we actually discuss several vertical industries and their drivers. I do not think that we have in this presentation time to really
happening in IEEE, GCAIoT, within its technical, industry, and government tracks?
Oh, absolutely. I think it's a great portfolio of this conference, because I've been with IEEE activities since the late 80s and early 90s until today. I believe that this event really symbolize a great accomplishment in our long journey, going from primarily academic focused to having a great presence of industry, as well as the government element. I think it's a very good conference that actually brings the whole ecosystem together.
I see. So as long as we are talking about this conference, the IEEE, so what is the most interesting thing that you liked about this conference? Like you must have attended tons of conferences this year, but what is the most special thing that you've liked about this one?
I think definitely it's multifaceted contents and the participants, because you need to bring in different elements. Both there are a lot of conferences. 60, but here we are really talking about the collective effort. So it is going from where we are, looking at the path to 60. So I think the comprehensive scope of that, as well as I think, for example, I just listened to a talk from, I believe, the speaker in our joint 5G summit and the industry summit design of the I think it is very exciting, very creative view of the future that is close to it looks almost like space age time, but I believe the technology coupled with the 5G network enablement, I actually try to ask a simple question about the amount of time to but very exciting. And not just talking about theoretical or that are relatively mature and run-of-the-mill realization. Really groundbreaking and really exciting news, but it looks like maybe we're going to the road in real life. I think that is exciting.
For you, Dr. Chen, is Expo 2020 is our next station, actually. So in your opinion, what is the impact of being part of such a massive event?
Expo 2020.
Yeah, as we know, it's been postponed to next year. So.
Oh, yes, yes. Actually, we also know that a very important other event that's called the Olympic was also postponed, right?
Yes.
So I think 2021 will be a very exciting and busy year to have.
I guess so, yes.
Events. And
hopefully.
It will give us more time to show more mature and ready to deploy new technologies. I'm very excited, looking forward to it. Yeah.
Yeah. Okay. So I want to thank you so much one more time, Dr. Chen, for being with us. It was such a pleasure. I enjoyed the interview myself. So
much. I'm also very excited and happy to see that we have more and more leaders and key players of our gender in this ecosystem. Like you.
Yes. Yes, we still have women in tech also tomorrow. So this is interesting.
Yeah, look forward to that as well. Yeah.
Yes, sure. Thank you so much.
Thank you.
advance and attract the ecosystem when it comes to artificial intelligence. And the third arm, which is recently has been launched, which is the National Center of Artificial Intelligence. So the role of the National Center of Artificial Intelligence is to focus into innovation and research. However, in our national data and AI strategy, our vision is that how can we have the best of data and AI and make it a reality? So first of all, we need to answer three main things. The where, which is how can we develop and create the adoption of data and AI technologies across the kingdom, and that definitely includes the research and the educational ecosystem. And the second thing is that the best of data and AI, how can we innovate sustainable and practical ethics of data and AI adoption? And most importantly, how can we have it, how can we make it a reality? How can we attract an ecosystem of world-class infrastructure, test beds, environment, data governance, commercial incentives, government-sponsored initiatives, minimum red tape, uniqueness, and many, many others. Before, in the previous experiences that the government had with research and the relation with the universities was a little bit broken. So now we're looking at it as a whole ecosystem. And that was the reason to develop the National Data and AI strategy with focusing on 6 strategic objectives. We call them Aspire. So they're coming from 6 main dimensions: ambition, skills, policies and regulations, investment, research and innovation, and ecosystem. And under each of those 6 strategic objectives, we have 16 initiative streams. If we focus into the research and innovation and what are some of the initiatives that we're trying to work on in the upcoming year, so we're activating the strategy beginning of 2021, is one initiative stream focusing on research and innovation excellence. How can we elevate data and AI, R&D, and innovation capabilities in universities and research centers? So there is a huge stream our colleagues are focusing on. We're going to activate that stream, inshallah, next year. And the other one is actually how can we build national innovation test beds to create and attract data and AI test beds environments in Giga Project and smart cities, such as NEOM and such as the work that we're currently doing also in Riyadh City. And our vision is to make Riyadh one of the top 10 smartest cities in the world, focusing onto AI and data. And most importantly is really the ecosystem. How can you really have an ecosystem of supply and demand? We have the supply. However, we need to focus into the demand and creating the right business models and the right problems. We're currently trying to focus with research and universities into 5 key sectors that we believe are of a key priority and high priority to the kingdom, and we feel it's more the same to the region, which is education, government, and healthcare. I believe the colleagues have already addressed some part of the healthcare, energy, and mobility. Mainly, we have activated 2 priority areas, which is the energy and mobility. I can give some examples about some of the work we're trying to do right now with research and academia when it comes to the energy. So far, we have seen that AI technologies could improve citizen lives and improve the resource allocation, mainly the energy saving initiatives. There are several applications that we are currently working on towards the development of energy efficiency, homes, and intelligent building managements. We're using artificial neural networks that we have found so far to be extensively used to predict building energy consumption, to reduce power consumption through the studying of human behavior patterns, especially during the day and at night. And so far, we have found that there are so many good insights that we could come up from here. So this is a work in progress that we believe we're going to come up with the good insights that will hopefully reduce the consumption of energy in the kingdom.
It looks very impressive, Engineer Nasser. And what type of projects already started? I think they are already on the map and you just started. Because the authority, I think it was launched last year, correct?
It was in August last year. The strategy itself was launched in October of 2020 when we had the Global AI Summit. So right now, the activation of the strategy will start working in 2021. However, at the same time, we're working on to many other strategies, such as the national smart city strategies. And the focus over there is that how can we help cities in Saudi Arabia optimizing the resource allocations, especially when it comes to the infrastructure and the assets that the city has, such as cameras, such as sensors and IoT data and mobility. So we're focusing into mobility also right now, is that how can we leverage the cameras and the video analytics that we have to really solve many issues that we have found that are promising in the kingdom, such as the average waiting time and the travel time between one point to another, having it more efficient and reducing the time and reducing the CO2 emissions when it comes to the mobility aspect. So these are still at the beginnings, I would say. We're looking to release and issue some of those initiatives in the upcoming couple of months. And then we would like to ask all the industry leaders to come and support us in those initiatives.
Okay. Now my next question, and this is exactly related, I think, to the continuity of Engineer Nasser is saying. We have a huge ambition, we have government vision, and we have the will to implement artificial intelligence in all means in different countries. Now, are we ready to implement them by using our local resources from engineers and from talents of artificial intelligence? And what's the strategy of building the right talents of artificial intelligence locally in different countries? Dr. Husni.
Yeah, I agree, Dr. Ahmed, that the main challenge is the skilled manpower, especially when you're talking about
So, Dr. Hosni, are you facing a connection problem, or is it just me?
I can't hear Dr. Hosni.
I think Dr. Hosni is having a connection problem again. So, I don't know if you can hear us. I think you can try to refresh your internet or like log out and log in again. Yeah, you can hear us well, but actually we can't hear you well. Yeah, so.
I think I see Engineer Nasser. You hear me?
Yeah, we can hear you now loud and clear.
also was wondering if you've ever looked at the energy consumption or energy efficiency perspective, like for this such a kind. I mean, it's an interesting application, I'm sure, but I was wondering, like, more to the practical side. I mean, have you looked into these issues?
Yes, we have like for the energy efficiency, because well, the edge usually doesn't have any. I mean, we assume that the edge device is much more powerful, and obviously it's powered by the supply line and the AC outlets. But still, we also tested like with the Raspberry Pi and this kind of like single board computers, so that if someone wants to, let's say we went to forest and we just have like a battery power available, which is still, for example, the Raspberry Pi or the Intel Up Gateway can still serve as a gateway for even weaker devices run by, let's say, ARM microcontrollers or some like Atmel microcontrollers. So in that case, what happens is like we can still run our algorithms, and we saw kind of like about 20 to 25% processor utilization, even on the Raspberry Pi and that kind of like single board computer. So I would say like, and we also measured, like presented in the paper, we have some current draw, so we can more or less estimate how long the battery life is, you know, like how much we need to put, like, let's say, is it do we need a like a higher capacity battery, or just normal, let's say 5 ampere hour battery is sufficient, right? That kind of thing.
All right, thank you very much. If we don't have any other questions from the audience, I think we can move on to the next paper. Can we have any of the following speakers? Do we have, I don't know who's with us today. Let me see. Wael Abdullah, is he with us today?
عمر مع حضرتك يا دكتور.
Amar, yes. Amar, who's next?
Dr. Wael.
Yes, okay, so Dr. Wael, do we have Dr. Wael with us today?
I can see him in the attendees, so I can play the video right away.
He's not in the attendees, right? I think we have. Okay. Okay, but if he's not around, then maybe we should not play his video, because he should show up for the presentation, right?
Okay, as you say.
Yeah. Okay, so we'll have the third speaker with us. I think it's Dr. Ren Song. You have Dr. Ren Song with us? Hello? No?
Dr.
Have Antti Normanen with us?
Yes, Antti Normanen with us.
Okay, can we play the video for Antti Normanen? Could you please introduce yourself, like give us a short bio, and then we'll play your video, if you wish. Hello, Antti, are you with us? Hello?
Hello, can you hear me from here?
Yes, we can hear you. Fine.
On my PC, because I had some issues on the laptop on Wi-Fi. My PC is on Ethernet. So, okay, so I'm Antti Nurminen. I'm from Aalto University, and my interests are mostly in mixed reality, mobile 3D maps, but recently I have moved towards IoT and related things. I have been research fellow on Aalto University, but that ended just in this spring. So I have moved to industry and ad. Thank you. You can be
but with explainable technique, we provide also the explanation, like what is happening inside the black box.
As you can see in the
On the picture's right-hand side, this AI has tried to
is one of the example of the enhanced mobile broadband.
And Huskies.
And smart city or smart
on the top line, we have prediction of wolf. Yes, it's wolf. Predicted husky. Yes, it's husky.
And also industrial automation, mission critical application.
Great, it's going well. And then on the lower line, predicted wolf. But it's husky. And what's going on? So the small pictures on the right-hand side of the animals are actually showing the segmented parts of the image.
From the massive capacity point of view, the
AI.
key requirement for the
AI was segmenting and trying to figure out what's going on. So actually, the animals themselves are not even part of that. They're just kind of random pieces of background which were used for this classification. And what was happening was that if there was snow detected in the picture, the AI was predicting wolf always, not caring about the actual animal at all. For humans, this is so.
For machine type communication is the use of IPv6 addressing, as you know.
Huskies have more whiteness in their face, right?
And this slide showed 5G use cases.
So for plans, we attempt a little bit similar way. We will use textual output, where we try to tell the user what our AI was using as variables, which were important variables like temperature and humidity. And then what was the status? Okay, so for that now temperature is high and humidity is low, so it's too hot and dry. And now moisture and illumination are imbalanced. So roots cannot absorb water as fast as leaves transpire. Try to provide this kind of explanation of what our system has analyzed.
And ultra high
Our data consists of environmental conditions, which are input, soil moisture, humidity, temperature, and illumination. And output is plant condition. And okay, how do you tell how healthy a plant is? Well, we assume that the healthy plant reflects near infrared from chlorophyll, but absorbs blue and red. From this fraction, you can calculate the normalized difference vegetation index.
Compared to the
if it's positive, it should be okay. It gets calculated between -1 and +.
How many industries will use?
If we were really smart, we would use computer vision to try to
business to government.
All kinds of illnesses or brownness from leaves, but good luck with that. It's actually quite complex. So we hope that the NDVI, Normalized Difference Vegetation Index, will suffice.
I think this is something like the initial
now our architecture is composed of
in the 2020 the Olympic
some ESP chips that read in sensor data.
So
and Raspberries will transmit the combined data to backend using open messaging interface, which is a standard protocol. We store everything in a database, and then within the Django framework, our AI agent is analyzing the data, and also Django is generating UI for our users to view the data and the plans.
This kind of the new radio is used with
microcontrollers, BMA 280 chips for humidity and temperature, and ADPS 960 for illumination, and capacitive soil moisture sensors. And so the ESP is transmitting this data from each plant via Wi-Fi to our Raspberry Pi, and that is our input.
Then for the state of the plant, we created a box with controllable blue and near infrared LED strips, and we took photos with Raspberry Pi no IR camera, both from near infrared and blue illumination, and we ran a segmentation algorithm based on OpenCV and PlantCV, and then central Raspberry Pi transmitted that to OMN node. OMI ODF, Open Messaging Interface, Open Data Format for transmitting data back and forth, and a user interface.
For the next release or expansion of the 5G,
some results, we tested a few plants in advance and realized that the camp plants, like cactuses, the cacti, they are not changing their state in any reasonable time. So we chose basil plants, which are 10 of them, and varied illumination and moisture for a period of 17 days. We had a reference plant which we just kept in darkness and didn't give any water to see if the NDVI is going down. Yes, it was going down. So there was hope for
Tesla, he had it on autopilot, and he was busy watching the Terry Farm, how much he really was. So he never noticed that there was a truck wiped out on the highway, and the truck bed was blocking the road. Tesla never
so we need more dense feed NDVI sampling. Actually, we have already created boxes where we can keep our plants all the time and sample NDVI like every 15 minutes and every 10 minutes. But the installation was not yet by far ready for average guys, average Joes, so we had to students for the university's software project and Finest Twins for partial funding.
It can process LiDAR information, radar information,
and
sensors,
are there any questions?
The grounds, the traffic lights and landmarks, even auditory information. It's actually a well-known fact.
Thank you very much.
You can hear that little
do you have any questions
across
from the
street
audience?
before you see the kid run across the street. Taking in GPS, all these things together, machines can actually process thousands of data points in real
have
time.
A quick question.
And imagine that car can actually know what's beyond that blind left turn before it makes the left turn. That's actually why the big debate we have in the UN isn't about when will autonomous vehicles be fully legal on streets, but when will we have to ban human drivers,
data collection
right? Because we interject more variability into the system.
Was too sparse.
So this is another notion of convergence.
We actually did build
something that I actually got to work on. We were looking for an efficient, short-range, energy efficient, green energy type of transportation.
We had an external box where we had to move.
You see here is a bus called Ollie, and it was designed by
move around. It
IBM's
would never
AI
be in the same pose.
This bus is autonomous.
The NVI would vary.
It is solar powered.
Causing too much noise
for the 3D printable.
To detect anything like small details.
Very good. Call up to 12 people. You can have a conversation with Watson as it drives you around. But it's also very cheap to make. Has a lot less waste in production and retirement.
Right. So do you have anything like
like you said, it's 3D printable and it's solar powered.
Counteract
so it's energy efficient.
This problem.
But this was something that came about from AI design
that we were
using what we call generative design,
often we were able
where
to see,
AI
example,
actually generates millions upon millions of designs,
allow us to
even fabricating materials that we haven't seen sometimes,
that,
to try and find an optimal solution. It'll narrow that down to like its top 7 to 12 choices, and then the human engineers come in and take a look and see which one of these might be the most viable.
Hours of delay. So
we get something like Ollie through that convergence.
Granularity earlier. So now it's
another, healthcare is on top of our minds and a big need.
Small changes happening.
We're already looking at combining AI, IoT, VR
latencies
to actually create non-invasive ways to examine patients.
How fast we can see.
So imagine being able to see a patient, their medical history, all the information
condition changes
without having to open them up.
If you
by actually using things like lights and CAT scans and MRIs and
any light or water. Sure,
and there's already a prototype for the heart. So doctors are kind of playing around with this, where you can actually have a XR image of the heart that they can, like Tony Stark did in the Iron Man movies, see the heart, rotate it around, open it up, even check the ventricles without having to open up the patient's chest. And of course, agriculture, one of the most oldest industries in human society. Another great example of convergence. So here we're combining drones, IoT, AI. We're looking at things like weather data, soil content, potential insect infestation, that even like farmers in Bangladesh, they don't need a huge infrastructure or even high-speed Wi-Fi. They just need access to a tablet with some rudimentary mobile connection, and they're getting help from all this data. So we've seen things like where even planting your seeds 2 millimeters to the right, planting this type of crop, this type of topsoil, they're actually able to improve crop yields by more than 30%, using 1/3 less water and using less of that topsoil resources. So we can actually have a much better chance to grow more food and feed the world. That's kind of how I want to end my keynote here. Is there's a lot of powerful things we can do with this convergence of technology, right? We all know that there's new capabilities with each one of them, but combining them together is actually unlocking whole new opportunities for us. And that's no more evident than the social enterprises, social entrepreneurs that are doing something that's commercial, but also trying to create a positive impact in the world. And initiatives like the United Nations AI for Good is a prime example where we're trying to create the ecosystem, the mindset for engineers, for domain experts, for solutionists to find opportunities to come up with something innovative, but hopefully that also has a positive impact that helps people that may be homeless, or help people find jobs, or provide better healthcare, better access to education. So can we solve a lot of the big world problems? We sure can, thanks to convergence. And with that wraps up my part of the presentation. Thank you.
Thank you so much, Mr. Neil. I think we have all really enjoyed your keynote speech. I am looking forward to see you again. And thank you one more time. I would like to invite you and
as well as some scattered organizations. So first, this is about IPC. It's an ISG. This is programming, meaning that we can change the routing, we can choose the routing at the beginning so that we can control. So this can be, this can if we are using like this. The third one is smart connection. So
Okay, welcome again, our honorable audience and guests. It's the time for another panel of this day. Innovation is a key to a whole new world. In the industry of IoT and AI, this can be a very helpful, innovative is the world. About innovation in the IoT and AI industry, we will have our panel today to learn more about the new ideas in these fields and how they can revolutionize our world in the coming years. This interesting panel is being moderated by Dr. Sudhindra, the Vice President of the IEEE, and he is hosting a number of well-established figures in the AI and IoT industry. The floor is all yours, dear Dr. Sudhindra, to welcome your guests and start this interesting panel.
Thank you. Thank you so much. It's an exciting topic. Of course, it's the most relevant and very well researched topic as we speak. But I'm more happy to have this exclusive panel of very learned people with me. I have with me Dr. Alok Nath, who is a good friend of mine and a colleague at IEEE. He does a lot of wonderful stuff at Samsung, so you will hear more from him when he speaks. I have Mr. Sri Chandra, we call him Sri, from IEEE Standards. He's a senior director at IEEE India office, located in Bangalore. And we have with me Mr. Santosh, who works with NTT and doing really wonderful work. Some of the use cases that I was talking to him about. I think it's a pleasure and an honor for me to be able to host the three gentlemen who are very, very experienced and stalwarts in this area. Just to open the floor and before we get all of them talking about their perspectives, it's very important that at the time we are in to understand what IoT and or AI can bring and maybe even together. Fundamentally, this is a conceptual stage where a lot of research is happening and also a lot of innovation is happening. Obviously, the discussion will be the difference between the two. I got a very wonderful definition from Dr. Nicholson of 3M, who says research converts money into knowledge. You fund a project, you initiate some research studies, and you get something new out of it. So research converts money into knowledge, and it says knowledge converts that innovation converts that knowledge back into money. So I think you convert that knowledge and make some new products and services which are helpful to the community and the humanity. So I think that's the conceptual stage we are in, where both are running hand in hand. So there are multiple applications, including during COVID times, pre-COVID times, I'm sure post-COVID times, in multiple domains, whether it's automotive, telecom, medical, you name it, you have it. So without much ado, I would like to invite Sri Chandra to start with his thoughts on this topic and then share his views in the next few minutes, please. Sri, over to you.
All righty. Let me just share everything. All right. Hopefully you can see my screen.
Yes.
Ravindra can see it. Okay. Yes. So thank you, Ravindra. I won't spend more time on introduction. I work with IEEE, and in my previous life, I used to work with the Freescale and Motorola. So my focus for this panel is going to be mainly on standards. I work for the IEEE. Within the IEEE, I work for Standards Association, where we develop standards in all these very, very interesting area. In fact, I do agree with Sudhindra. I think you cannot decouple IoT and AI today. If you look at edge computing and all the things that are happening on the edge and the cloud, it is getting very, very integrated. So I thought I will start my presentation with the impact. All of us have been using Wi-Fi devices. Today, if you go to the airport and see each of the persons sharing, going through the security, the number of devices that they have, 5 to 6 devices each. So if you look at the cumulative Wi-Fi devices, they are predicting that there in 2022 there will be 35 billion devices, and you can hear some number as 50 billion devices by 2025, and so on and so forth. And I used to think very pessimistically, but I think these numbers will accelerate and we will get them sooner. And in our own lives, we reflect upon it. And today, without Wi-Fi, I think it will be a very, very different market. And this is just on the consumer segment. And then if you go to the industrial segment, there are studies by McKinsey, and this was a while back. I think these numbers are probably higher. Industrial internet will touch 43% of global economy. And I'm not surprised at all. Even if you look at what we used to call as traditional industries several years back, perhaps a textile industry, a mill. You would have thought that, okay, it does IT and OT would not enter it. Today, you have embedded sensors, you take data, you make decisions on the data. So there is no vertical that is practically not touched by Internet of Things. And that has given rise to new business model, new business approaches. Today, we don't have to stand in a queue to buy a ticket or book a taxi. Everything is coming together in the framework of Internet of Things. And on top of it, intelligence is being added, and they understand your preference, they understand what you would like, and they give helpful sessions. Sometimes it's pretty scary that it's very close to what you yourself are thinking. So I wanted to touch upon a view of IoT. When I see on the right-hand side, you hear a lot of people talking about cyber-physical systems, Internet of Everything, the networked world, the connected world. And what do these things have in common? A concept of deep digitization, IT-OT integration. It's driven by the world of sensors, where you are generating data, you are capturing data, you are storing it, you are making analysis of the data, and you are again closing the loop. You are making some decisions on it. So it's all about a closed loop design. And today, machine learning and deep learning is one of the hot topics, where it is just not about collecting data, but making decisions on the data and making appropriate decisions on the data. This slide is perhaps the most important slide here. We used to always worry about the functional aspects of any technology, right? How fast it is, what is the power saving, all these functional requirements. But today, when the impact of technology is being felt much more broadly in the society, it is touching the end user, it's touching the common human beings. There are a lot of other requirements that take very, very critical viewpoints, right? So TIPS is a framework that we are looking at within IEEE, where we are looking at trust, identity, privacy, protection, security, and safety, right? Security no longer can be an afterthought. People are worried about who is aware of their data, who has agency on the data, who owns the data, whether it is you or the provider or the device manufacturer. There are so many steps on the way, and where does your data reside and who owns it? So in the backdrop of all these things, I wanted to touch upon a few standards that we are working on. Of course, we cannot not talk about 802 and 802.11 when we are talking about IEEE standards. And that is driving a lot of innovation in IoT. Today, in fact, this year is the 40th anniversary of IEEE 802. It all started way back when in 1979. And it is considered as one of the technologies that can be leveraged to meet the 5G requirements. And it will be a peer radio access technology within the 5G architecture. So there are three prongs to it, the 802.11ax, which is called the Wi-Fi 6. Then you have the sub-gigahertz Wi-Fi, which is looking at wearables, sensors, smart home. And then you have the millimeter wave and the 60 gigahertz. So all these three are looking at different dimensions of driving Internet of Things use case and applications. Within IEEE itself, there is a large array of work, maybe close to 100 standards, which touch upon IoT in various aspects. Either it is about protocol, or it's about the non-functional requirements of TIPS framework, trust, identity, security, or it's also about concerns of well-being, like how much noise devices are emitting, what is the SAR, how should the devices be able to handle these things. So these are all the impact that we are having in IoT, and there are several verticals, right? There are horizontal standards, and then there are standards that touch upon specific verticals. There is the Internet of Medical Things, IEEE 11073. Then there is the power line communication, which touches upon energy, so the smart grid vertical. So there are each vertical, transportation and automotive. So there are several verticals which are defining specific aspects within the vertical, and then there is the horizontal, and which is all coming in together as a melting pot within smart cities. It is becoming a very, very complex ecosystem when we are deploying these things. It's multidisciplinary. It is a very large system of systems. You cannot look at it from an enterprise view anymore. So in that context, the work on autonomous and intelligent systems become very integrated and very important. IEEE developed a seminal work a few years ago called the ethically aligned design. So this is talking about what should be the ethical considerations when we are talking about autonomous systems. And then this is a very broad framework and a document which is available for free. And then they started looking at specific verticals, and you can see very interesting verticals.
considered personal. That's based on a ruling with respect to the GDPR. And even if it's not directly tied to a person, there's also been a ruling that a dynamic IP address can still be considered personal if it can be indirectly tied to a particular person at a particular time of day or time of year. So that's even considered personal. And of course, financial transactions, which is what blockchain is typically used for, those are, of course, naturally personal data. And the second major proposal for dealing with personal data on the blockchain is to be able to encrypt the data and then destroy the key that's used in a manner of deleting it. So the idea there is you record the data on the blockchain in an encrypted form, and then if you want to delete it, you just get rid of the key. But the problem there is that, of course, it's personal data, so it must be secure for decades. And if you look at the progress in cryptography, you'll see that typically a cipher that is secure at one point in time, in 20 or 30 years, it may no longer be secure. So that is a problem for data that has to be available for decades. And of course, there are other advances coming in. Public key crypto systems will be affected and put at risk by quantum computing when there is a practical quantum computer. So that's a second problem with trying to deal with privacy issues on a blockchain. The constraints that we used and in looking at another approach for the block matrix, one is that the hash integrity, the integrity of the data must be secure for everything in the data structure except for the blocks that are deleted or modified. So we have a similar sort of hash integrity requirement. We also assume that deletions will be relatively rare, so it's not something that will be happening in milliseconds, but maybe seconds or minutes. That's relatively rare. And one of the main goals is to ensure accountability and auditability. So that's a key point of blockchain, is we can guarantee that this data is accurate and was put in there at a particular time. And we also assumed that this was not going to be used for cryptocurrency. Now it may be possible to use this data structure for cryptocurrency, but the assumption was that it would not necessarily be done. So this is how this data structure works. So we have rows and columns, and the idea is to be able to use hashing, which are the H values down the right-hand side and along the lower row. So each row stores a hash at the end of that row, and each column has a hash for each column at the bottom there. So every block within the matrix is protected by two hashes, the row and column hash. And again, this is suggested for a permissioned data structure, permissioned distributed ledger system. So let's look at how this works. So if we wanted to delete a block, in this case, it's block 12. So that would disrupt the hash value of H3 right here, and it would disrupt the column hash value down here, column 2. But the blocks of row 3 are included in other hashes, and likewise for the columns. We have two hash values for every value of the block. So as you can see, if we change block 12, then there are hashes still protecting all of the other blocks. This is the algorithm, the way it works. It's actually very simple, just a few lines of code. But let's look at how the matrix is populated. So it starts off in this point where 1 is shown, then 2. So it goes back and forth across the diagonal. And there's a reason for that, which we'll talk about in just a minute. But as you can see, it goes back and forth like this. There are a lot of different variations. There's already been a new variation by someone in Europe that just thought it was an interesting problem and made a change and made it work in a little bit different way. But the key point here is that we go back and forth across the diagonal, and that allows certain properties. So the first is that we have balance, of course, since we go back and forth across the diagonal. So the upper half contains no more than one additional cell than the lower half. And of course, the length of the hash sequences for the number of rows or columns in the hash is going to be constant, as it'll be proportional to square root of n for n blocks. Another point, which we don't get into here, but this can be done in a multi-dimensional data structure. So n is not always 2. You could do 3, 4, 5 dimension matrices if you like. The number of blocks, of course, it's going to be for the k in the number of columns or number of rows, k squared minus k, just because the diagonal is null. And of course, there are no consecutive blocks that appear in the same row or column. So as you can see here, let's say if we look at the first row, row 0, we have 1, 3, 7. So we don't have 1, 2, 3. We disperse the blocks across rows and columns, so we don't have 2 consecutive. Properties of this, it's a pretty simple data structure. It's easy to code and to build. You can store very large volumes of data, and we can extend this, as I mentioned, to n-dimensional arrays. We can modify or erase blocks while ensuring the integrity of all of the other blocks. And of course, because the way it works, we can do very fast consensus algorithms. We don't need the large, complex proof of work. And we can use timestamps for sequencing guarantees. So now that we've got a quick overview of how it works, this is an application of where it's used. So this is next generation database access control. And the idea here is an attribute-based system. So it uses attributes such as for a user, the attributes might be the employer, the clearance level, the division in which the employee works, and so on. And resources have attributes such as their security level, their location, and that sort of thing. So attribute-based access control looks at these attributes and operates based on rules that apply these attributes. So one of the key points is that the attributes tend to be stored in different locations. For example, it might be a credit score for an individual that's used by a bank. So these attributes might require going out to another organization to obtain the data and then apply that. So that's one of the things that we can do, is we can eliminate the need for that with every access. So we can use this to provide an integrity guaranteed value, which changes relatively slowly, and then we don't need to do access over and over to all the different organizations. The way that this database system works, again, we don't need to get into the details because of time, but the attributes are passed around among multiple organizations. So that's one of the key problems that we can address. This is what it looks like. This is the data. Again, this is
technologist, tech investor, and the author of Tech Nomads of the Universe. His speech is one of the most interesting speeches because it's discussing the new space, internet, and how it interacts with the 5G technology. Let's learn more about this with Dr. Riyad in this keynote. So the mic is yours now, Dr. Riyad. You can share screen and go.
Thank you very much, and it's a pleasure being here. Let me share the screen. Okay, can you see my screen now?
Yeah, I can see your screen now, Dr. Riyad.
Okay, very good. Yeah. So thank you very much for the introduction, and it's a pleasure being here and joining you from. I happen to be on Pacific West Coast, so it's 4 in the morning here. But it's a pleasure joining you. As introduced, basically my background being primarily in the internet space, working on developing internet infrastructure for the last 20-25 years. Primarily in startups in Silicon Valley, but also as an advisory practice. So Zona Partners is an advisory practice that I've co-founded and doing primarily work in anything internet infrastructure. So today I picked this topic of space internet because I believe that it's one of the most exciting things happening at the moment. For a number of reasons, and I will come back to them. And we'll be focusing on this new generation of low Earth orbit constellations, assessing the opportunities and the challenges. So I picked a picture from probably over a year ago, and there was some like quite a bit of background noise back then, with a number of like lights in the sky at night, and people were wondering what that is. And it's interesting that digging more into it, you know, people realized that was some satellites being launched, the SpaceX constellation, in the early days of testing, I believe, and that was probably sort of. You know, one of the early instantiation of these new low Earth orbit constellations moving forward. Fast forward to today, like a year and a half, quite a bit of progress. And I'm going to be describing some of that, see where we are, see what are the opportunities, the challenges, how it works with the mobile operators, with 5G, with fixed wireless, with also interfacing to cloud networks and a number of other things, right? But before that, maybe very briefly, like few words on what do we really mean by this low Earth orbit constellations. Typically, it's what you see on the right side of the screen is this geostationary constellations. I put some examples there that run at about 36,000 kilometers. And they are the ones that we get most of the satellite networks from today. And then we have the emergence progressive of what we call NGSOs, like non-geostationary satellites, which include primarily the low Earth orbit and medium Earth orbit. So on the low Earth orbit, you see them on the left side here. So they basically orbit at different altitudes from 500 kilometers here till about like 1350 for some of the constellations. And there are a number of things going on here. This is not the first time that we see these low Earth orbit constellations come into market. We've had a wave about, you know, in the 80s, 90s. And actually the results were not that successful back then for a number of reasons. And this is probably a new iteration of that. And I think it's a fast moving, there are lots of constellations going on, being launched, a lot of services offering, being planned, but still it's very early stages, and it remains to be seen how this whole thing will progress, but we are off to a good start here. So there are a number of reasons why we're having these constellations back into action. There is one side, the demand side, in terms of like internet services and with specific quality of service, with specific latencies, with specific service delivery quality of service, and so on. And there is also the constellations angle in terms of like launch technology, satellite technology, and management of constellations technology that have progressed very, very fast over the last 10 years, let's say, right? And this is what's leading to all this momentum at the moment. A number of players are involved in all these initiatives in one shape or another, either building constellations or funding them or partnering with them. So you see the major internet players here. I listed few. You have the large technology players as well, involved either funding or building. And again, you have the venture capital community. You have the existing geo satellite communication providers, as well as government-funded consortiums in multiple countries around the world. A number of deployments are going on at the moment. There are small constellations all the way to very large constellations. You see some numbers here. I think you will have them like, split in multiple categories. Some constellations going after broadband, others going after 5G, others going after Internet of Things, some focused on residential, some focused on businesses. So it's a mix and match of multiple constellations with different technologies addressing different markets. I think we are in very early stages here. The market is still open. There are a number of initiatives, and things will progress. And the key question is in what shape and form do we see these constellations evolving? Where would be the sweet spot for their markets? And then obviously how they will basically be part of the end-to-end internet value chain. That's something to remember. It's really like seeing these as a component of the end-to-end value chain, and that's probably how we see this whole initiative evolving. I picked some numbers here in terms of some of the constellations that are gathering pace at the moment. Constellations such as SpaceX, which is probably the most advanced at the moment, Kuiper from Amazon, OneWeb, which has already launched their constellation, and Telesat, which is upcoming. So you see some of the numbers in terms of satellite deployed, and these are just examples out of a number of other constellations that are being planned. You see a number of satellites that go from the almost 300 to about 4,000 satellites in the first phase of deployments, the altitude at which they're launched, the frequencies at which they operate for downlink and uplink. And I think the most important characteristics here really is what you see in terms of latencies. One of the most important characteristics, I would say. And I think the fact that it brings these low latencies is really what makes it as a key differentiator versus the geo constellations. And a lot of the promise of the benefits and the service offering is around this low latencies that these constellations can bring. Not the only advantage, but one of the key advantages. Anyway, having said that, one should step back a little bit and try to understand what's really getting us to this point today. On one side, we have the requirements. We have the requirements as far as the IoT connectivity, especially to extend the reach and the coverage of mobile operators, as an example. We have the requirements in terms of services that require low latency, low cost, and very importantly, the notion of having connectivity anytime, anywhere, which is not really the case today, and specifically in the emerging world or in the rural areas in part of the developed world. So that's on the requirement side. On the satellite market trend side, I think some key characteristics here is the fact that we're having new constellations that have sort of optimized the launch costs and the satellite build costs that have progressed fairly aggressively in managing the spectrum rights. and also been like very active in integrating aspects of like 5G and IoT, mobile edge computing, optical space links, and a number of other things, and the design of their constellations. So we have this balance of requirements and the market trends driving the satellite constellations, and you know, and one has to go deeper and see what type of use cases one sees for these constellations. The use cases are fairly broad. They would go from you know, basic connectivity in different types of conditions for different types of devices or users or services, and applications across multiple industry verticals. We see quite a bit happening in transport industry, in the offshore industry, in critical communication, public safety, as well as government services. So what you will see is different internet constellations. Low Earth orbit internet constellations will be specialized in specific market segments and start their business there and then evolve into other businesses. That's all good. I mean, there is a lot of investment. I mean, some constellations are basically looking at about $10 billion just to basically finalize the constellation, build, launch. So these are fairly significant numbers. It doesn't apply to all constellations. You have smaller ones with like 100 satellites or even lower that will come at a lower cost. Depends on the service being offered. So there is a lot of momentum, a lot of action, a lot of investment, a lot of technology, and I think energy is there in terms of moving them forward. However, I think it's very important to take a pause and see what would be like the challenges that a lot of these constellations would see. We're seeing them today, like, you know, number of business challenges to start with. So I listed few here in terms of, like, you know, start with, like, you know, with the risk of funding drying out, which we've seen about 20 years ago for the first generation of these LEO constellations. There are issues that relate to what the revenue stream challenge to overcome is the cost of the
player in the international scene of IoT and AI. I believe this will be very beneficial for everyone who is interested in this. And please let me ask Dr. Muhammad Al-Khawaja, Angel Investor, CEO at Startups, to welcome my guests here. And you have the mic, Dr. Muhammad.
Thank you. So it's a great pleasure being part of this great conference. Like IEEE always collect great minds around the world, and now we're lucky being part of this great event about IoT and AI. And focusing on the region is my best interest. When I travel abroad, I always tell the MENA region has a big potential. We have the talent, we have the ambitions. We have some limitations and challenges, and that's why we're here to discuss them and see how we can take things forward. So without further ado, I'd like to welcome my esteemed panelists, and I'd like to start with Mr. Ahmed Sidqi, the head of digital business at Vodafone in Egypt. And also we have Dr. Hussein Natche, the serial tech entrepreneur and CEO at Mujaz and the chief AI at Mawdu'. We have also Mr. Ahmed Abul Yazid, who's the Launch SaaS Incubator Manager. I'd love to give each one of you gentlemen like 30 minutes to 1 minute just to brief us what exactly you do, so that the audience would get a background about what you do before I deep dive into the discussion. So I start with Mr. Ahmed and ask your good self, kindly let us know what you do at Vodafone, what you do in your professional and across your career, especially what's relevant to IoT and AI. The floor is yours.
Thank you, Mohammed. Thank you also to the conference team, IEEE team. This is my honor to participate in the conference for second year. Last year was physical. Hopefully the next year will be physical as well, inshallah. I'm currently leading the business solutions in Vodafone Egypt. I'm responsible for the end-to-end B2B service that we offer for our enterprise customer, including connectivity, messaging, cloud services, IoT services, big data, and AI. Previously, I was leading the innovation and the R&D team in technology, and before that, I was handling the network team in some of Egypt. So I was 16 years in Vodafone, currently focusing on B2B businesses and focusing mainly on digital B2B services.
Great. So maybe we can hear more about IoT and how IoT is taking the business division inside Vodafone to the next level. I'll move to Dr. Hussein Natche, who's part of a great key player in the region, Mawdu'.com. And also Hussein has been really a great entrepreneur himself. He started an AI company years and years ago, and then before he got acquired and joined Mawdu' as well. So I'm excited to hear and introduce the audience about you, Dr. Hussein. So please, the floor is yours.
Thank you, Mohammed. It's a pleasure to be part of this panel. Good afternoon, everyone. My name is Hussein. I'm a specialist in data science and AI innovation and applications. As Mohammed said, I started my first startup back to 2009, was specialized in offering AI data science services. We had a few clients in the region and also outside in the US. 5 years ago, I was acquired with Mawdu' and started, I would say, one of the biggest AI teams in the region. We managed to bring back some catalysts in AI and pioneers from Europe, US, and also we managed to hire and develop a data science researcher and engineers from Jordan, Egypt. We have now 10 data scientists in Egypt, 20 in Amman, Jordan. Mawdu' starting investing in AI, we built a toolkit in understanding Arabic language. It's available for everyone through a link of ai.mawdu'.com. We're using this technology to develop many services now going in the region and also globally. One of the best or most famous is an Arabic voice assistant called Salma. Now Salma is going to help the banking sector and also call centers to automate and make their services better. We also use this technology to launch Qalam.ai. It's a Grammarly-like service but specialized in Arabic for spell checking and autocomplete. And lastly, a new subsidiary that I'm heading today in Mawdua Group, which is Mujiz, is a personalized recommender system that aggregate Arabic contents from sources like news, sport, and entertainment and make a personalized experience in a mobile application.
Very interesting, Hussein. Thank you. I move to Engineer Ahmed Abul Yazid and ask you about your great experience when it comes to SaaS, incubator, working with startups, product management, all these key talents that really required for the ecosystem to grow and expand.
My name is Ahmed Abul Yazid. I work for Nilepreneurs, which is an initiative funded by the Central Bank of Egypt, currently hosted at Nile University. We mainly focus on supporting SMEs technologically. We have an incubator pillars, which have lots of software startups that we support. One of the incubator vertical, we can say, is the software as a service, which actually have a lot of IoT startups that provide solution for SMEs, and that actually include some AI components. So I'm more than happy to share with you my experience.
Okay, so thanks again for this brief introduction about your good selves. I'll move and ask you the key question, maybe the $1 billion question for the region, which is basically, what do you think the missing part of the AI and IoT ecosystem in the region? What's really affecting us from really expanding? Is it really we're not getting the right amount of education? Is it really the funding? Is it really the entrepreneurship spirit?
Can you hear me?
Academia?
Yes,
what do you think?
I can see you too.
The missing part of the recipe that makes our ecosystem thrive and grow in this key part of the world, the middle East. I'll go through this discussion with all of you. So, Engineer Ahmed,
I can hear you.
How do you think, from your perspective, from the private sector, what do you think?
Shall we start our interview now?
So,
can you just tell me what it's going to be like? I mean, just so that I
the IoT ecosystem
know what we're going to do.
Is much different actually on AI ecosystem. So I will divide my answer into what's my view or what I can see in the market in IoT and AI. So for the IoT, I still see that our region overall and the emerging countries specifically in our region is still lagging a lot in IoT. From my point of view, this is mainly because of the long value IoT services. The IoT service is not an easy thing to be done. So it is consistent initially from the hardware part, the sensor side, the gateway. Then bit of the connectivity, which is almost the easiest part of the story, and the software or AI.
So I would like just to know if you can hear me, because I can't really hear you. I don't know if you are facing
use case or the expert ROI.
Yeah, your link is dropping every now and then. Okay, now it's gone. So I don't know who is on the line, but you're getting suddenly disconnected or muted.
And this long value chain is mainly disrupted by the first part, which is the hardware and the hardware integration. The big investors that can provide hardware and get it even manufacturing or exporting is not seeing the real ROI. So the value chain is linked with the awareness, linked with the expected ROI that we told the customer that we will have. That all of this is delayed or lagging. To work to enhance, we have 2 points here. Number one is increasing the partnership ecosystem. How is the partnership is collaborating together? How we support the small startups or small innovators to join the big giant in terms of starting the value chain. And the other part, which is the application, I think it's easy, as well as the AI part. So for the AI, the data is there, a lot of data. that's already existing in the operator side, with the banking sector, with other big giants, and the bit of the organization that can build on operate any AI solution. موضوع, as we have Muhammad here, which Hussein here, which is very good example for that. He built his data. He has the journey of, we don't have this content to build this data. So the AI part was initiated of the personal data. We have who have his data, like for example, Vodafone or banking sector that in need for the AI solutions. And as we have Hussein, so I got to discuss موضوع in specific. موضوع is
hello again, Dr. Sudhindra. Can you hear me?
Data, so the
yes,
AI
now I can hear you and see you. So it was you're getting muted
I
for
think that the AI is different story. And
I don't know what's the problem actually, because we are really facing some very bad problems. Google also is down. I think all around the world now. So I don't know
expenses
what technical issues
of cost is a bit less
are we having
than the value of
so shall we start?
Yes, so, interesting insight. Yeah.
Encouraging this part.
Welcome, Dr.
Big organization is trying to monetize their data, make use of it in terms of customer value management, increase the customer value we have.
Virtual conference.
For operators and
going through this virtual experience, how do you think technical conferences will be in 2021?
Interesting.
Yeah, I think.
So,
thank you,
Dr. Hussein, how do you see the missing part of the AI or IoT ecosystem? What's prevent us from really building a great ecosystem in the MENA region?
The prognosis for 2021 officially
is a big question, Mohammed. But yes, we should talk about this more and discuss the challenges.
Mode or hybrid.
Maybe I would more talk about the AI side than IoT, because maybe it's my
mode of
specialty. I can't agree enough with
you, is very important, but that's not a choice we have this year,
in the part of like the lack of hardware.
So virtual conferences are very important,
when
and
we
I
talk
think
about IoT.
That is the reason that we have
from my point of view, the challenges are not only one or the biggest one. There's many challenges
which get us closer to the physical mode.
And even we're facing in the last few years as well. The biggest, if I want to show, is the right investment.
Much better than just a WebEx session or a webinar to listening to
long and big investment.
This conversation, you have a backdrop,
also the entrepreneurship, I would say, ecosystem.
A couple of people moving around. That gives me a feeling that
focus
it's
more
a hybrid.
on technical innovation.
So a couple of days ago,
there is many opportunities, many problems to solve. And I believe that if we focus on regional or local problem to solve, this is where we will have like a competitive advantage, and then we can actually provide innovative solutions that both the market of MENA and also multinationals and global international companies can also partnership with us.
Like 500
so I agree again with
Ahmed. I was really laughing hard, but I was muting my mic because it seems
maybe the shortcut or easiest
I think we all have to
tool for
this,
us to do.
change in our life.
So the hardware
as you know, the conference objective is to support the integration among the academia, industry, and government.
In both of them,
how do you see this happening in
I think now
IoT with its
the world is like becoming more connected, and there is no other option than collaborating
to get these people come together,
other providers.
Meet them, get something
even big companies today like Apple, they partner with China to manufacture things, and Korea and other and Japan. So you cannot like act alone.
Make that idea become
especially in our region, we have like a lot of small countries. We have big countries and big economies like Saudi Arabia, for example. But still, comparing to other countries in Europe, in North America, and in the Pacific area and in Asia, they still do this collaboration. So I think there is another challenge here.
I think they all have a lot of wisdom and experience.
Like collaboration and big projects.
The idea is now when I come and present
have the whole
paper and disappear, I don't get much out of a conference.
Key partners, I would say,
I could do it virtually
to work together and long
the reason I would come to a conference is to listen to
again, it's not the one challenge. I agree with you, Muhammad, as well. There is the education part. But today, this challenge is becoming less effective because
there was a gentleman who was asking,
my point of view,
what can I do in my region?
In the field of AI,
to learn and make
the online courses and
so I think this cross-fertilization
But one of the things that I liked in GCAIoT is the platform is making it easier for people to come together. So they know who is online, they know what's going on. In a hotel, usually you have those displays where they tell you which session is going on in which room, right? So I got the same feeling here when I got into the platform. I saw the topics, and there was this live now, and there was this backstage and stuff like that. So what I like the most in this is it helped me navigate. It gave me a feeling of a physical conference.
Yeah, great. So my last question, and I'm very sorry if I took much of your time. Expo 2020 is our next station. In your opinion, what's the impact of being part of this massive event?
Yeah, so I think it's a very important time that this event has happened. And I think we had a lull before this event due to the stage we were in COVID. I think now the end of the tunnel is near. We are all talking about the how part of the vaccine, not if and when. So I think that's a great discussion to have. I think the impact is huge. The impact is going to be, I have made so many notes today, and I was, like I was saying, people have made so many notes. I think even if you can put 3/4 of that into action, we would have start seeing result very early next year. And I think all of us can do that, and I hope all of us will do that. And I wish all of us, including the organizers, the very best to take it further to the next level.
Thank you so much, Dr. Sudhindra. I enjoyed being with you today. Looking forward to seeing you again in Dubai Expo 2020. Thank you so much.
Thank you so much. I look forward to meet you in person as well. Thank you so much.
Thank you.
Nice. So I could see people behind you, and it was nice to see that again. Take care.
if you do post-training scheduling, then you look at the local and global model dissimilarity by things such as Euclidean distance, pairwise similarity, and divergence, or you can look at parameters dissimilarity by looking at again at the Euclidean distance and the pairwise similarity or L2-1 norm. And we showed that by using these diversity measures, you are able to perform training and an accuracy in less communication rounds compared to what we call a vanilla federated training, where you don't select your devices depending on the diversity they bring in terms of data composition or data generation. So to sum up, there are very interesting things to do in terms of edge computing by having the training of your intelligence done in the devices with the help of the edge. Some of the challenges regard the energy that is available in the devices, the time you want to do the learning, and your algorithm design needs to take into account device selection, resource allocation, and how you update your aggregation of models from your devices. And you have to play with things such as limited bandwidth, limited battery, and size models. And diversity measures are very important when you do this kind of models. And there are different diversities measures that you can use either in prior to training or after training. So based on data set diversity or model diversity, so basically that's my presentation. So I have talked about intelligence, issues of privacy and latency. I have talked more in details about something called federated edge learning, which is a multidisciplinary problem between finally communication, 5G, and artificial intelligence. I talked about design challenges and trade-offs, and some of the problems in terms of communication, energy, and data scheduling. Data properties are often overlooked in this kind of problem, but it's interesting to see how we can use data properties in terms of diversity when we schedule the training devices, and some promising results have been found, especially in terms of how we can achieve very accurate models without even ever engaging the data in the cloud and outside the devices of users. So this ends my presentation. Please feel free to ask me questions.
Dr. Shumaya, so there is a question in questions tab at the right screen, on the right side.
I'm not sure. I cannot see it.
In the right
I cannot
side of
see.
Screen, a questions tab. You can go in it. Okay. Can you read the question?
I can't see questions.
The question is, what about IoT devices that should be working for a long time without recharging?
Sorry, what about?
IoT devices that should be working for a long time without recharging.
That is an interesting question. So the IoT devices, the energy preservation is one of the very important things to consider in this kind of schemes. You need to be able to ensure that your device will stay alive after you do some kind of training in the device. So the models have to be very light, and also you can do less training.
Organically, we'll get more who are really like unicorns or maybe international players. What's really the right approach? For example, you're working as part of an incubator. Do you really take your full capacity in AI or IoT, or you go beyond that to really just focus on very few, but really make them very powerful in their area? What's your approach, and what do you think that works best in AI and IoT? Mohandas Ahmed.
Okay, so in the last question, I addressed a number of challenges regarding the IoT. So let's talk now about the proposed solutions. So for the talent pipeline, we have a huge shortage regarding to AI and especially IoT. So a condensed boot camps or education programs that have a certain goal in mind of creating your own project at the end of this condensed program could help. Especially we have a lot of tech students in the MENA region. I have seen some statistics about that. And actually, non-techies actually could jump on board of this hype. The second challenge of there is not enough business application or opportunities for a certain technology, which is IoT and AI. So I think industry players, whether corporates, SMEs, governments, need to develop a list of challenges or micro challenges or opportunities or problems that they are facing that could be solved by Internet of Things, especially I think in the Industry 4.0 area where lots of automation needs to be done, and there is a huge infrastructure of factories that need to be upgraded to be ready for the industry 4.0. So there is a lot of opportunities in that. Also, in Egypt, we have a list of upcoming fourth generation cities, which is semi-automated and fully automated by Internet of Things and artificial intelligence command and control centers. And actually, the government have proposed a lot of tenders for local companies in this matter. I think we must have at least 15 or 10% of local companies to provide solution for those cities. So there is the challenges or the lack of business application challenge part. And the last part of the market itself, should I go local first or global? I personally prefer to go for off-the-shelf IoT product with a software as a service model, so that
you're biased towards SaaS, right?
So this is actually the IoT startups that join our incubators. We push them toward this approach in order for them to be scalable from day one. And actually, we tell them to position and brand themselves as an international citizen or an international startup from day one. We found that actually attracts lots of local opportunities. So we serve both purposes, the scalability and capturing local opportunities.
Great. So I want to ask Hussein because
excuse me, Hamad, if you don't mind, I want to add a comment
please
on health technology, because it's very good for the growth of the region overall. If we want to support the growth, we need to support the startups. So the startup usually is supported by two ways: the investment, which is the role of VC and the incubator, to work on what is the product and how to grow and how to invest in vegan. The other part of the story that we usually miss or don't talk about it, which is how to support them to grow in terms of revenue, how to give them the proper channel to try and make these products available for especially the AI and the IoT is the majority of the system. The ecosystem is B2B rather than B2C. So for B2B, the main player usually government, which is invested in that domain. However, government usually also rely to adopt startup product because it's already implemented in the big system, impacting a lot of people. So usually government not going for the most corporate and SMEs and so on. It's the real part where the startup can and how can they generate. However, to reach the corporate and SME part of the business, it's very hard to avail the right channels. Starting from government program or a corporate program can support the startup more faster than just
Interesting perspective. So I'd love to ask Hussein to shed about his experience with the European startup landscape. Hussein, studied and lived for a while in different parts of Europe, and you did your PhD there as well. So can you share part of the expertise? Do you think the European ecosystem wants to have more startups serving Europe or become global? Do they have the same type of challenge?
mobile nodes. As I see that they have failed to select more parameters for the selection of mobile nodes, whereas in our work we have also considered the mobile nodes also. The third survey we compare it with the ant-lion optimization approach, and the limitation with this protocol was it failed to utilize the constraints like sensing capabilities and the delay in other applications. So this is the workflow or the flow chart which we have followed. First of all, we simulated the network and we actually used MATLAB in this. And how the network works actually is, first of all, what it does is we form a network with a limited number of nodes, and first process is to select the cluster head within a wireless sensor network. So the nodes are deployed first of all in a particular square meter area, and the nodes are placed randomly. And once the nodes are placed randomly, they form clusters in itself. Once the clusters are formed, they choose a cluster head. We'll see the details in the coming section. And the second step is the checking the node candidacy, like which node is eligible to become a cluster head. Then in the third step, we calculate the energy levels of the cluster heads, and then we terminate the algorithm. Now, this is the proposed entropy-based weight-based leech protocol. As we know, the basis or the main fundamental of the leech protocol is this formula which we see 1 upon 1 minus C L mod L of C. Now, what happens in this original leech protocol is, this leech protocol, as I said, first of all, the nodes are placed randomly, and then the clusters are formed. And within these clusters, they have to select a cluster head. And these cluster heads are responsible to communicate with the base station. The nodes are communicating with the cluster head, whereas the cluster head only communicates the collected data to the base station. Leech protocol was that once a node was considered for a cluster head selection, in the next round, as we all know, the leech protocol works on the number of rounds. So the negative or the disadvantage of the leech protocol was that once a node has been selected for the cluster head, it is not being considered for the next round. So what happens is the disadvantage is that once a node which already has, suppose the node has not been selected as a node has sufficient energy to become a cluster head in the second round or the third round also, but because the node becomes the cluster head, and after, even though it becomes a cluster head, it has sufficient energy to become cluster head in the second round. But the disadvantage of this leech protocol is we do not consider the already nodes which have been already treated as the cluster heads. So we are actually not giving optimum energy balance. We are not giving enough. And here is we have considered in our method, we have considered the nodes also which are already taken part in the cluster head formation. Now this is the formula, Rn is the threshold value, and this threshold value is the basis for the cluster head selection. C is the percentage of sensor node that can become cluster head, and H is the node that did not take part, and L is the current node. This is the basic formula of the leech protocol. R of N introduce an entropy value. The value for R of N is equal to minus B log of B. So Bn is equal to is 1 minus FL upon L. What is FL? It is the time the node N acts as a cluster head, and it is divided by the current round, and it is being subtracted from R. So what we have done is actually we are considering both the time, like as I already said, we are considering the time when the node has already been selected as a cluster head. So we are taking that into consideration, and it ensures that we give better energy balance to all the nodes and equal participation opportunities to all the nodes to become a cluster head. Now, these are the results which we obtained for our simulation. First of all, we considered 50 nodes. We have taken the parameters like alive nodes and the energy. Like we all know, the alive nodes are the nodes
these are the results, and this results
the number of alignments which have been left after the termination. As we see for 50 nodes, we have compared our protocol with the existing BGP protocol, the hybrid MFO, LFO, ALO, and the As we see, for the 50 nodes, the number of alive nodes is marginally better than compared to other protocols. Similarly, when we go for the energy, we see that we have a good number of energy increase in the proposed protocol. Now considering we have considered the same scenario with the 100 number of nodes, and for each scenario we have considered 1000 rounds. As we see in the graph on the x-axis, x is the number of rounds, and the parameters we have considered as the same. First of all, we have the alive nodes, and we see for 100 nodes also we get more number of nodes as alive in our proposed protocol, and also when we consider the energy part, we see a marginal increase.
And the parameters we have considered as the same. First of all, we have the
as I said, we have what we have introduced into this is a new part which we consider all these nodes to be mobile also, which has not been done in all the earlier works. So considering this mobile nodes, the best model which we have selected is the log-normal sharding model, and we have simulated this network in the backlog with the log-normal sharding characteristics, and we have done the same simulation for 50 nodes and as well as the 100 nodes. And we are using the same parameters, alive nodes and energy. Let's see what happens. So in this graph also we see that for the mobile nodes also, our proposed protocol performs better in terms of compared to the other protocols in terms of alive nodes. Similarly, when we see the energy part, we see a marginal increase in our proposed protocol compared to the other protocols.
Our proposed protocol performs better in terms of compared to the other
same parameters, alive nodes and the energy. As we see now, when we increase the nodes from 50 nodes to 100 nodes, the number of alive nodes has increased considerably in our proposed protocol compared to the other protocols. Similarly, but for the energy part, it's not a great increase in energy, but it's okay.
The number of alive nodes has.
Now let's come to the percentage of nodes reduced after 50 nodes and 100 nodes. How much nodes have been reduced after the communication? As we see on the x-axis, we have the percentage of nodes, and y-axis has the number of rounds. After 1000 rounds, as we see, for the 100% nodes, after the 100% nodes are reduced,
as we see on the x-axis, we have
that our proposed protocol in the green bars does better.
Y-axis has a number of rounds. So after 1000 rounds, as we see,
that our proposed protocol does better than the already existing protocols. This is the lifetime of the nodes, and we see that
does better. And also for the 100 number of nodes,
is the number of the nodes. And when we see an interesting pattern over here is when we increase the number of nodes from 50 to 100 to 150 and 200 and 250, increasing number of nodes and also mobility involved in it, we see a proposed
X is the number of the nodes. And when we see an interesting pattern,
the average node lifetime, which was our basic purpose of the simulation, is actually being fulfilled here.
Increasing number of nodes and also mobility involved in it.
To conclude, we did a modification in the existing leash protocol to make it suitable for the mobile wireless sensor networks. We can see that we have future applications of vehicle communication and maybe used in other areas also. And we see that our proposed
a modification in the existing leash protocol to make it suitable for the mobile wireless sensor
the presentation. These are the references which I have used. Thank you so much for your time. Thank you so much for listening.
And we see that our proposed protocol does better.
Thank you.
Compared to the other existing protocols. That's it with the presentation. These are the references which I have used. Thank you so much for your time, and thank you so much for listening to me. Yeah. Thank you. Brilliant. Thank you very much, Prina.